Alright guys, one more rational equation example I'd like to show you. A situation where instead of just a plain old x in the denominator, we actually have an expression now. So you can see we have x minus 2. Alright, and so for starters, I need the restriction on x, which means what can x not equal? Said another way, what number can I not plug in right here? Because if I do, I'm going to get 0. So if x minus 2 cannot equal 0, then all we're saying here is that x cannot equal 2. So again, if I do all this work, I cannot get an answer of x equals 2. Alright? Second thing I want you to notice here, only because I see so many students do this, this is just a 3. Alright? 3 is never going to be 0. That'd be like saying if you have $3, you're really broke. Alright? It doesn't happen that way. So we can ignore that when we're thinking about the restrictions because there's no x there. Alright, next thing we need to think about before we begin solving is what is our least common denominator? Okay, well I have two matching denominators of x minus 2 and I have a denominator of 3. Do these somehow combine inside one another? No. One thing I oftentimes see is x minus 6 or x minus 5. No, let's just grab our different denominators. I have a 3. I have an x minus 2. X minus 2 is an expression in the same way x was in the previous example. I don't need to square it because there's two of them. Once I have one, I'm going to be able to cancel both of them. Alright, and I'll show you exactly what I mean by that. So again, what am I going to do with this least common denominator? I am going to multiply it by every single term up here. So I have 3x minus 2 Okay, so here I have multiplied, as you can see, every single term by this least common denominator. And just like in the previous example, if we did this right, we're going to end up with no fractions. Alright, so let's see if we did this right. Does this expression, x minus 2, cancel? Absolutely, it cancels with the x minus 2. Alright, same thing here. Does the x minus 2 cancel? Absolutely. It goes away. It cancels with the x minus 2. Alright, and then here, does the 3 cancel? Yes, it does. Alright, and so let's see what we have left over. We have a 3 times x equals a 3 times 2, which is 6, minus an x minus 2 times a 2. And I'm going to write that 2 first and then the expression involving x, just because that's typically how we read math. Alright, and now you can see, just like I promised, we have a linear equation that we need to solve that's pretty simple. It involves only integers, no fractions, no x's in the denominator. So let's work on solving this. Alright, the first thing we need to do is distribute the 2. Alright, and so I'm going to copy what I have down, the 3x and the 6, minus 2x plus 4. Now how did this 4 become positive? Because this is a minus 2 times a minus 2, which double negative makes a positive. Alright, can I simplify this side? Okay, this is not telling me 6 minus 4. Remember, I'm combining them with the operation directly in front. And so I can combine the 6 and the plus 4 and get 10. Okay, and then the final step here is to get these x's over here. Right, so how am I going to move these minus 2 x's? I'm going to add 2 x's to both sides. And here, let me actually go ahead and change color on that. Plus 2x, plus 2x. All right, and that gives me a 5x equals 10. Okay, and so if I have 5x equals 10, how am I going to solve for x? Again, it's opposite operation here. So I'm dividing both sides by 5, and I get x equals 2. Okay, do I go woohoo? And in my math lab, immediately either select the answer of x equals 2 or type in x equals 2? No. Why? All right, let's look at the board. Why can x not equal 2? Aha! X cannot equal 2. Why? Because if I plug this 2 in here, I'm dividing by 0. which is the one number, remember, we can never, ever, ever divide by. So what is the answer? Well, how do we say nothing in math? We say the null set or no solution.